Please. So loud. Okay, first of all, I normally don't teach density to upper sec students because I really think it's a very trivial concept. But many of you may not think so because of the way you learned it in school. Your starting point with density is always the formula. So I believe that the formula is going to mess up the way you understand the chapter. From some of our new students' work today, I think it's quite obvious. So I'm going to tell you why it's logic and common sense. I will use Chloe's example. I was asking her what items she likes to buy. So she told me she likes to buy clothes, right? Okay. So you told me this month you spent $140. Okay. Now let's just imagine, right? For some reasons, you like this line of clothing, but this brand, but they have got 8 different shades of color. And you decided that you want to buy all 8 of them. All right. So you want to buy 8 clothes. Okay. Now let's keep it simple. The price tag on the shop says that it's $6 per cloth. It's $6 for one. Okay. So you have the intention to buy all 8 of them. Now, how much will this cost you? How much will this cost you? Use logic over here. $48, right? Okay, great. So what brand do you like? Give me a brand. Just give me a brand. Sorry? S-H-E-I-N. Are that right? S-H-E-I-N is Shein, right? This is called She. This is called In, right? Shein. Okay, never mind. Anyway, so this is the brand you like. Now, but something unfortunate happened. Listen, on the way home, you dropped 3 of the colors. So now on the way home, how much are you down with? Now you got how many? You have 5 clothes. But you really like the fact that all of them are nicely color coded. You know, the rainbow has 7 colors. Let's just imagine the 8th color is black, right? So you got the whole rainbow and black, but now you're missing 3. You cannot make the whole collection. But you pass by another shop that happens to sell the same 3 color that you were missing, but it's another brand. But you don't want to go home without the 8 clothes. So you say, I'm going in, I'm going to buy this 3 now. Okay. But it now costs $5 per clothes. It's cheaper, right? But it's a different brand. This one is called She Out, you see. So you don't want to buy She Out, you want to buy the Shein, you see. So let me ask you, how much would you have spent over here? No, because you're here to buy how many? You're here to buy 3 more, right? So you're going to spend $15. Now, you go back home, you take a look at all the 8. 1, 2, 3, 4, 5, 6, 7, 8. You look at all 8 of them. Of course, among these 8, 5 were the ones that you bought in Shein, right? Then there's another 3 that you bought at Sheout. Then your mom asks you, okay, so girl, today how much did you spend? How much did you spend? You don't want to tell her you lost that 3, you see, it's so embarrassing. So she'll ask you, how much did this 8 cost you? Would you agree you will tell her, okay, this one cost me 15, and then this one cost me, now how much did this cost you? 30. This one cost you 30, right? So am I right? So you say, okay, mom, today I spent, okay, I only spent $45 to buy these 8 clothes. What a life, right? So listen, how much did you spend per clothes on average? 5.625. You understand this example about looking at things that you buy and all those things? You need to learn this. You need to learn the formula to do this calculation here. No need, right? You're very good at buying stuff. I'm sure you never go and think of formula how to calculate how much you don't do that at the shopping mall, right? But now, when I give you this density question, suddenly that's what you do. Everything you do is formula. Now take a look. Of course, this is a very boring example. It's not buying. This is the $6 per clothes. The cube has got 2 cm each. So the total volume here is the 8 cm cube. Understand? So, Sherlyn, I was telling you, when you see 6 grams per cm cube, you need to learn how to see this as every cm cube is 6 grams. So now you know that this cube is a total of 8 cm cube. You must be able to say, okay, it's actually total mass of 48 grams. Understand this part? Then I talked about somehow on the way home, you lost 3 of them. This is what they say when they say that they drill a hole and they remove 3. You understand? Okay. So they remove 3. So when they say they remove 3, how much did your mass change? It's no longer 48 grams. You have to minus 3 times 6. You understand what I'm saying here? Understand? So now you say, okay, the mass is now 30 grams. It's like saying that the remaining 5 clothes that you have, the total value is $30. It's like the total mass now is 30 grams. Then you went by another shop, right? And then you buy 3 more. It's like another material we use to fill up the hole that we have. So when you're filling up, we are using another material. This is where I talked about the new clothes cost $5 per clothes. You say it's cheaper, right? Yeah, so this is like a cheaper material, a lighter material. Then from here you can say, okay, you know, my new mass is now 45 grams. But because my volume was still total of 8 cm cube, you can now take this mass over the volume to find out what is the new density, 5.625 grams per cm cube. But you see, my point is, you need me to teach you this. You need a formula to do these things here. You don't need, right? If you can calculate how much you spend and all those things, you can do this as well. I give you time, you copy this. Okay, so I think enough of this analogy, but you get my point. This topic is really all about understanding what this unit stands for. Like over here, we'll see that in the next question. So the question now says that there is a water level that rises from 10 to 35 when a hollow ball bearing of lead is placed in a cylinder. Now, I think this is going to be an important thing. What do you think a hollow ball bearing is made out of? I think this is a very profound question. What is it made up of? Most people will not get this correct. It's made out of air. That's the first thing you think of. It's made out of lead. That's the main thing. But what is it also made up of? Air. Okay, so it's made out of these 2 things. Agree? Now, when they say that the volume rises from 10 to 35, you can take 35 minus 10 to tell me that the total volume is actually 25 cm cube. You agree this part? Yes, this part should be easy. Then they give you information about the lead. Take a look at this. This is called 11.3 gram in every 1 cm cube. Get this? And then they say that the mass of the air is negligible. So when we say that the ball bearing is 226, how much of this 226 is because of the air? 0, none. None of it is contributed by air. So can we say that the 226 gram is really just all the lead? So can you do this? Are you able to use this mathematics relationship to find out what is X going to be? You do this now, everybody. If 11.3 is going to occupy 1 cm cube, then 226 will occupy 20, right? So what does this 20 stands for? This is the volume of the lead. So this lead here, we put 20, but we know everything is 25. Then is it obvious what this will be? This must be 5 cm cube. This is the thinking behind. Let me bring it back again. Understand? So it's 5. It's really that simple. Okay, Barsha, take a look. This approach is how you should be thinking. You did something else, but you're not wrong. But I think yours is too complicated to get this answer. Shirley, understand this now? Chloe, understand? Not difficult, right? Okay. So pause recording here. So number 5, actually number 5 is much easier to do. Okay, let's take a look at this question. You have a cube that is made up of 2 different materials added together. Eventually, the key information is this. They tell you that the total cube volume is 27 cm cube. And the combined density now becomes 3. So what can we do from these two pieces of information? It's frozen. Okay. So this is 3 grams in 1 cm cube. Because we know that the total is 27 cm cube. From here we can say, okay, the total masses. So we know the total mass, we know the total volume. Look over here. They tell us the mass of A is twice the mass of B. So I'll put A and then I'll put B. The mass of A is twice of B. So can we say that there is, this is 2 units and this is 1 unit that add up to 81 grams. Understand this part? Okay, so this is 2 units of mass and this is 1 unit of mass that adds up to 81. Then from here you can find out what is these 2 units, right? You take 81 divided by 3, you should get 54 here. This will be, is it 54? Can someone check for me? 54 and what? 27 grams. So this is how you figure out what is the mass of A and B. But if you take a look at this 27 cm cube, they tell us that the volume of B, so this is volume is made out of B plus A. But how many units is B? They say the volume of B is twice. So we can say that this is made out of 2 units of volume B. This is 1 unit, which add up to be 27. So this is 18 cm cube, and this is 9 cm cube. And when finally they say find density of A and B, you match the A and A together, 54 and 9. This can give you 6 grams per cm cube. And then if you match up what is B, this will give you 1.5 grams per cm cube. Understand how to do this now? Okay, so back to what I said earlier on. These 3 questions, my Sec 1s, of course not all of them. Some of them really can do all these 3 after learning density from me, right? So how did I teach them density? I never teach them. You see, you notice until now, have you seen a single formula I used to describe density? The formula is this, of course. Density is equals to mass over volume, but this is really not going to help you with the thinking process. So why I call this density multiverse? Only in this universe, in my universe, you learn density like this. You now learn it. Yeah, you want to learn mine, you must ask Dr. Strange to help you create the portal and come to my class and learn it this way. Sorry? Yeah, all the different methods come in. Okay, so I will pause recording here. So I mean record because I want to make it known that the next question that I want you to do, and it's not easy, is actually 13. The 13 is not easy because of part B. Okay, so you all do this now. I forgot the answer. I need to do it with you. Because the student who first showed me this question, she was a Sec 1 girl from RGS. Her name is Sarah. And this question was from her school test. In remembrance of Sarah, my ex-student, I decided to name this document and call Sarah. I'm not joking with you. So this is a question I saw in a Sec 1 RGS test. That was 2012 when I was started out teaching over here. So let's go through this. It is the part B that is challenging. So Sarah lowered a solid into a displacement can, then it overflowed. So the density is 1.2 gram per cm cube. And then the liquid mass that overflow is 4.2. Now, from these 2 information, what can you find? What can you find from here? You can actually find out what is the volume of the liquid. Agree? And how do we do this? So if you don't want to use the formula, you can go back to the basics. You can say that 1.2 gram. 1.2 gram is in every 1 cm cube. But because the total of 4.2 gram was measured, you can find out what is this, right? Press the calculator, tell me what this will be. Sorry? 3.5. So at the least, you should be able to say, okay, Mr. Ang, I know something about this solid. Because the volume of the liquid that flowed out is actually equals to the volume of the solid. What is the meaning of volume? What did I tell my students? Do you all remember what I always tell you about volume in Sec 1? What is the meaning of volume? Volume is the space that something occupies. So the volume is how much space it occupies. So when the solid is being placed in the displacement can, it kind of pushes out this amount of liquid. That tells me that the solid is going to occupy this amount of space. Okay, I stop here first. Understand this part. Understand from here that this solid that we put in has a volume of 3.5 cm cube. Okay, got it? Then in part B, now they tell you something more about this solid. This solid is actually have a total mass of 22.5. So with these two pieces of info, you can straight away write out this. You can straight away say, okay, I now know that the entire 3.5 cm cube is 22.5 grams. And we can find the density already. What does density stands for? Density really just stands for how much mass you have in 1 cm cube. So you take the calculator, tell me what this will give you. What will this give you? 6.4285, is it? 6.428. So I'll just put 6.423. I round out. Understand? So from here, this is important. This is telling us that the density of this alloy is actually 6.43 gram per cm cube. Okay, I will stop here first. Is everybody still following me? Shirley, you understand? Chloe, can understand? Okay. Now let's look much deeper into this. This 22.5 gram is made out of two different materials. The question told us it's made out of aluminium and gold. All right, so there's gold, there's aluminium. Okay, listen carefully now. If you look at the numbers given to us about density of gold and aluminium, is it obvious to you who is a much heavier metal? Take a look at the values. The density can also kind of tell you how heavy they are. So which one is a much heavier metal? Come, no need to take too long to think. Gold or aluminium? Gold is a lot more heavier, right? Okay. So my trick, my shortcut, without doing simultaneous equation, is to draw a number line. I will teach you again. So now you're going to draw a number line and tell yourself that when you mix two things together, you are using 2.7 gram per cm cube as one of the material, and then you are using 19.3 gram per cm cube as a material. Agree? Now, when you draw a number line, that this is what I call the extreme ends. Extreme. In other words, think about this. If I have 100% aluminium and 0% gold, look at this 22.5. You know that this is made out of gold and aluminium. But what if this 22.5 is all just aluminium only and no gold? What do you think the density will be now? Wouldn't it just be 2.7? Yes? So what if I say that this 22.5, it's purely just gold, 100% gold, but there is 0% aluminium? Then wouldn't you agree that if it's 100% gold, then this 22.5 gram, the density is just purely density of gold, 19.3. Get it so far? So this is where the magic comes in. In my chemistry class, my pure chemistry, when it comes to isotopes, I teach all of you the same thing, right? Who is in my pure chem class? Isotopes. Remember isotopes? So when you have two extreme ends, always think about what is the middle value. You calculate for me what is the middle value. If one is 2.7 and the other is 19.3. Do this now, quick. I'm sure you can do this, right? 11. So you add these two together, divide by 2. So 11 gram per cm cube. To get exactly right in the middle, you should also know how it works. Basically, you must say that 50% is gold and 50% is aluminium. Make sense? So if this 22.5 is because I have got half of it is gold and half of it is aluminium, then I know the density will work out to be 11. But look guys, what is the density here? The density is 6.43. So can you put on the number line where is 6.43? You can say it's here, right? Estimate lah. This is the 6.43. Understand? So you tell me, if this is 6.43, I've got more percent of what? And less percentage of what? Fill in the blanks. Where is gold? Where is aluminium? Can you understand why it's more aluminium and then less gold? Understand now? Is this clearer now? So now the question is, there's a very simple way to find out the more in terms of percentage. Use the distance. Now look here. You first find out what is the total distance between 2.7 to 19.3. What is the total distance? You take the calculator, you tell me what is 19.3 minus 2.7? 16.6. Then now you tell me what is the distance between 2.7 to 6.43. What is this distance here? 3 point. I'll put a bracket. Okay. This is what you do. You take 3.73. You take 3.73 divided by 16.6 to get the smaller percentage. Because this is a shorter distance. There's a longer distance, which is this one. I'm going to take the shorter one, which is 3.73, divide by the total. You convert this to 100% for me, times 100%, what do you get? 34.22.46. Let me just call 22.5. So from here, I know that my goal, which is lesser, the percentage is 22.5. Understand? So 22.5. So now take a look at the total volume. That means to say that the gold is occupying less space. When I say I got lesser, that means lesser percentage means lesser space. It occupies lesser space. So what is the total space I have? 3.5 cm cube, right? Okay. So 3.5 is the total space that it occupies. Now that I know that the gold is only 22.5%, can you tell me what this will give me? 0.787, is it? Okay, 0.787. This is the cm cube of the gold. Guys, this is the cm cube of the gold. Can you find out what is the mass of the gold? Because gold is 1 cm cube, 19.3. Right? Gold, 1 cm cube is 19.3. So how many cm cube I have? I got 0.7. So what is the mass? 0.787 times 19.3. What do you get now? Guess for me this. Sorry? 15.18, 15.2. This is the answer. You got 15.2? Okay, this is the answer. Sorry? Why cm cube? No, gram. The cm cube is the space. Okay? So the space it occupies is 22.5. When you do the calculation, the mass works out to be 15.2 grams. I'll give you some time and digest it. This is the not so mathematical approach. Later, I'll show you another way. Okay, so the other approach is to label them carefully, right? So what do I mean by label them carefully? Okay, let me just tell you what I mean. So this 22.5 gram, this 22.5 gram is the entire 3.5 cm3. Okay, so this is the information we have about these two mixed together. So I'm just going to call this, it's made out of Mg. Mg means the mass of gold, plus there is a mass of A, mass of aluminum. There's a certain mass of aluminum and gold that adds up to be 22.5. Understand this part? Okay. And then when you take a look at this, this is also the volume of gold plus certain volume of aluminum that adds up to 3.5 cm3. Is this making sense to you? Okay, so what equation can we form? We can say that Mg plus Ma is actually equals to 22.5 gram. Then we can say that the volume of G plus the volume of A is that 3.5 cm3. Understand this? These are the official equations we can write, right? But there's one more thing we can write. We can also say that the density of the gold plus aluminum, now I put G plus A because I've actually mixed them together, but the combined density is equal to 22.5 over 3.5, which we got this to be the 6.43 gram per cube. Okay, I stop here. You understand what I'm doing here first? Okay, so can we say that the 6.43 is actually equals to Mg plus Ma over Vg plus Va? We can, right? Okay. So let me see, how do we continue from here? Let me check what other info do we have. Okay, 2.7 and 19.3. Okay, so we have all this, but we also know that the Mg over the Vg, which is the mass over the volume of gold, is actually equals to 19.3. And we know that the mass of A over the volume of A is the 2.7. Understand this? So these are all the information we can write out. Let's do some substitute. Let's do some cross multiplication. From here, we can say that the Mg is actually 19.3 Vg. Understand this part? I cross multiply, right? And then over here, I can say that the mass of A is equals to 2.7 of the Va. Still following me? Get it? Now you substitute this Ma, you substitute the M in terms of V into this equation here. Let me do that for you. So I hope you know what I'm doing. I'm substituting this here. I'm substituting this inside here. I will now get 19.3 Vg plus 2.7 Va is equals to 22.5. But I've got another equation that says Vg plus Va is actually 3.5. So this is officially the two simultaneous that I saw. I get Vg and Va. It's very complicated, right? Sometimes in the exam, you may not know exactly how to get this 1 and 2. What you should do is you should list out all the things you know. And then if you're not stressed, you are very calm in the exam, you can start to see some links. I think this was an important step. Writing the 19.3 as the Mg over Vg and 2.7 as Ma over Va is very crucial. Once you do this, cross multiply, substitute, you should get it. Okay? You do this now? Yeah. So what Mr. Xia says is true. I do not know if you have done enough simultaneous equation to know, right? You can solve it without simultaneous. It's just like when we solve isotopes. When we say that one is X, the other is called 100 minus X. If X%, the other is 100 minus X. what you could have done is you can say one is X%, one is Y%. I know it looks complicated like this. I know, but why are you afraid of this? You are A math student, you can do simultaneous, right? Yeah, it's disgusting. Right. Okay, so what is, so can we make this neater, right? There's another way to, so Mr. Xia's approach, which is not to use simultaneous, is much neater, of course. Like, he used percentage just now. You use percentage to solve, right?
Actually, no, I just let the mass of
okay.
be X, then the other
Can.
one will be 22.5 minus X.
So mg, you let it be X. So earlier on when I say mg plus, you say mass, is it?
Yeah.
So when I say that mg plus ma is 22.5, you let this be X, is it?
Yeah. So that's the only unknown.
But we know the ma, is it?
Ma will be 22.5 minus X. So all the while there's only X, and X is what they want to realize, because they want the mass.
Okay, so actually you still have X and this stuff, but you only solve for this. Yeah, that is also another mathematical approach. Okay, so leave it to you. I know this is very an eyesore for some of you, right? Like a lot, like Chloe obviously don't like this, right? But this is not exactly neat as well. There's a lot of moving parts here as well. Yeah, but this one I think is more logical. I think without math knowledge, you can still appreciate things like, I got two extreme ends, right in the middle means 50-50. Use common sense here. So this is a bit more like common sense, but it's tedious still. But you can get the answer too. You try this formula, what do you all get VA, VG to be? Can you all solve this just for fun? Convince me that you're truly an A math student. Come. You're all staring at me, right? All don't do right thing, I don't know.
I can just
yeah, you solve. Tell me what is VA, VG. Nobody is doing it. VG 0.786, right? Now how far away is that from what we did? 0.787. 0.786, around there. So my approach is to remember volume as the space occupied. This approach is to just mathematically find out what is the unknown. Okay, I stop the recording here. So I continue to go through this question. It's very similar to what we did just now, where the number line can be very useful. So there are two materials, P and Q. P and Q, right, with the densities given to you like this. And later they give us another density. So I want you to look at these three density values given to you. You can now draw a number line and place these values on the number line. So we are saying that when you look at P alone, it's 10.5. And if you only have Q, it's 21. So what I like to do is always find what is the midpoint. Can you calculate for me what is the midpoint? You add the numbers together, divide by 2. 15.75. But you notice they give you another density information, 14. This is what happens when you become an alloy. So that means I can put 14 over here and then tell myself, this becomes the distance that I'm interested to take note of. I want to know what is this distance, because this is the shorter distance. And I also want to know what is the total distance. That's all you need. Find the shortest one and find the total. Now, what is the total distance? 21 minus 10.5? Sorry? 10.5, is it? Okay, 10.5. And what is 14 minus 10.5? This will give us is it 3.5? Agree? Okay. So this alone can, so take a look at the density. If the density 14 is closer to 10.5, that means we got more P or more Q. If the number 14 is closer to 10.5, that means I have got more of P and then less of Q. Make sense? So you always need to be mindful of which one you have more, which one you have less. So now I know there's less of Q. How do I find out the percentage? I take the smaller number over 10.5. So take the calculator, what is 3.5 over 10.5 as a percentage? What is it? 33.3, is it?
Right.
33.3. So 33.3% of Q. And all this calculation is based on the space. When I say there's more, there's less, I'm talking about space. So this is talking about volume. So look at what they want. They want the percentage of P by volume. But what we have found is Q. So is it easy for you to find what is the percentage here? That will be 66.6, right? Understand now? Get what I'm doing here? Okay. And then how do you find out what is the percentage of Q by mass? Because we know the Q, we know the percentage volume. So this is what you're going to do. You're going to take the total volume, which is 120 cm cube. The question tells us that the total volume is 120 cm cube. But we know that Q, it's only going to occupy 33.3%. This is the volume of Q. They want the mass. I take this, multiply by the density of Q itself, which is the 21. And then I can find out what is the, wait, they want the percentage by mass, is it? I'm doing this to find out what is the mass in grams. Can you all do this for me now? I take 120 times 33.3 over 100, sorry, not 1,000, over 100. This is the volume of Q times the density of Q. What do you get now? Sorry? 840. So 840 grams is my Q, the mass of Q. They want the percentage of the alloy. So I will take 840 divided by the total mass of the alloy times 100%. What is the total mass of the alloy? I take the density times the volume. I can take 14 times 120. Because 14 is the density, this is the volume of the entire thing. This will give me the answer. Can you calculate this for me? What do you get here? How many percent? 13, is it 13? 50. 50%. Okay, do you all know what I'm doing here? Understand? Okay, now I need to check my answer. Maybe I made a stupid mistake along the way, right? Oh, okay, I'm correct. Okay. But you notice the method here that they show us is algebra approach. Let X be the thing, then do this. Then there is something in terms of X. Then you got to solve in terms of X. And so on. Like whichever you like, whichever you like. As long as you know the method to get the answer. I can tell you, your teacher probably don't believe that you can get the answer doing what I've done here. Because they're not from our university. Okay, they're not from our universe. Yeah, you show them this, they're like, what are you doing? They even suspect you cheat, you know. They will be thinking you anyhow write things and get the value, but they probably don't understand this. Yeah, it's too deep. So now you understand why I do a multiverse lesson today. Okay, I pause recording. I got one more question to do. Okay, so this is the last question for today's discussion. $10 to the person who can get this correct. What is the weight of the water in the measuring cylinder? do this now. So Michelle, you didn't solve it, right? I didn't say you say anything. Now, why this is tough is because you need to know what does it mean when the thing is not fully submerged. The density of the water is given to us as 1. Look, 1. You need to make a smart guess what the density of this block will be, now that you know it's not fully submerged. So the trick is this. It is only 3/4 submerged, right? Can you see? That means the density of this thing is 3/4 of that of water. So this is the thing that a lot of people wouldn't know. What if something can fully submerge and float right like this? Then you can say that this is where the density is the same. If it's heavier, it will start to move to the bottom. Make sense? If the density of the block is heavier than water, it will sink all the way to the bottom. But what if it's the same? If it's the same, at the least it can do this, right? What if only half of it is floating? Then this also becomes very obvious. If it's only half floating, only half, then you know the density is half. Agree? So you need to know density is 0.75. So what is the volume here? Because it is only 3/4 submerged, that means now you need to study what is the volume of the total wooden block. 2 times 4 times is 80 cm3, right? So 3/4 of it, wouldn't that be 60 cm3? Agree? Yes? So that means this is 60 cm3. And what is this? This is the water. Let's go back to water density. The density is 1 gram per cm3. But I have 60 cm3. So what is the mass going to be? Agree, 60? This is the mass of water. If you convert this to kg, it's 0.06 kg. Understand? But they give you this. What does this stand for? This stands for every 10 Newton is 1 kg. So how many kg you have? 0.06 kg. So how many Newton will this be? 0.6 Newton. So you got it correct. Well done. You can do this, huh? Not bad. This is the thinking. Okay.